In this Algebra video, we are in Chapter 8, Section 5. We're going to talk about using the distributive property on polynomials. Specifically, we're going to be talking about factoring. So I'll quickly review the distributive property, but then we're mostly going to talk about factoring. So quick side example, 3 times x minus 4. Distributive property tells us 3 times x, 3 times negative 4. Well, that's 3x minus 12. That's what I mean when I say the distributive property. We're going to use that to go backwards in order to factor, and of course we'll talk about what factoring is. Alright, so that was your quick backstory. Your objective is, as the student, I can use the distributive property to factor polynomials, and I'll be able to solve equations of the form ax squared plus bx equals 0, and in other words it's going to be something like this. I'm just making this up. 3x squared plus 4x equals 0. We'll be able to solve that with factoring because I will look for common factors that I can quote-unquote pull out. And now I'm going to show you each of these, and yes, I will explain what factoring is for polynomials. Good news is you've already been doing it without realizing it. You've been going forwards, we're not going to go backwards. What's going to feel like backwards based on what we've been doing. I'm going to hit vocab a couple times during this, or vocab or how to. I'm not going to do it all together. I didn't want to jumble it all up. So our first thing is factoring. For our polynomials we're going to focus on. Factoring a polynomial involves, when I say I mean factoring a polynomial, those should kind of be together, involves finding the completely factored form. And in other words, what times what will give you the original polynomial. So, and let's do this example. I'm going to do this one kind of briefly. I'm not fully going to explain how to do it yet, but I want to show you how it's what we've already been doing. And in other words, let's take this step by step. If you were to factor this, or imagine what times what would give it to you. Now, I gave you the answer on the right, and I'll explain how we get it, but notice, if you were to use the distributive property that we just talked about and distribute this back out, you would get 24x plus 48y. But here's what's going to happen in this section. I'm going to give you the 24x plus 48y, and I'm going to ask you to work backwards. And here's how you do it. I am going to explain it with this question. Alright, when you do this, you look at anything you have. Look for something that they have in common. For example, this one has an x in it, this one does not. So they do not have an x in common. It's like dividing, you're factoring. So but they're both even numbers. You could divide both of them by 2, or by 6, or by 8, or let's go even bigger. 24 goes into both of them. So if you imagine, take a 24 out of both of them. So divide by 24, divide by 24. This is kind of what I'm saying. Or you could have just said the whole thing divided by 24. That's basically what we're about to do. They both have a 24 in them. Well, 24x divided by 24. So we're pulling out a 24. 24x divided by 24, well, that's just x. Meaning, if we were to put it back, we would do 24 times x, and we would get 24x. Alright, 48y divided by 24, well that's gonna give us 2y, because 24 goes into 48 2 times. Once you've divided both those by 24, you're done. It is now in factored form, meaning it's nothing but a bunch of things times each other. I understand there's stuff in here, but in general it's something times something. You have factored it all the way. Let's do a few more examples to lock that in. Take a look at this example and think about it to yourself. You might already know what goes into both of them. Well, 8 goes into 56, so we know 8 goes into both of them. X only goes in this one. X doesn't go into both of them, but they both do have an A in them, so you can take out an A. So you can take out an 8 and you can take out an A. So in other words, we're going to divide by 8A. So if we divided everything by 8A, meaning we're pulling out an 8A, you would then say, okay, 8a times what gives you 8ax? Well, that's just x. And if you're not sure, imagine you're doing the distributive property. 8a times x would give you 8ax, so it would put you back, which is good. Negative 56a divided by 8a, well, it's going to be a negative. 56 divided by 8, well, that's 7. And because we divided by an a, that a is gone. Now, to be very clear, you can show your work very neatly for this. You could do 8ax divided by 8a, and then you have negative 56a divided by 8a. So if you want to use skills we've learned in the past, this is technically what we're doing when we talk about exponent operations or multiplying and dividing with monomials. That's what this basically is. So if you really want to show your work, look at the left one. The 8 would cancel, The a would cancel, and look, you're left with x. So 8ax divided by 8a, you're left with x. Now look at the right one. The a's cancel, so the a's are gone. Negative 56 divided by 8, well, that's negative 7. So you know with x minus 7, well, hey, that agrees with what we had inside that parenthesis. So again, when you're pulling things out, it's really technically dividing. And it's like dividing, it's using all those skills we talked about back in chapter 7. Let's do another example. I am going to erase my work, though. Before I do want to confirm, if you wanted to check your answer, this works for everything we're doing in this section, feel free to distribute it back out, and you would get what you started with. That's a great way to check your answer. All right, let's look at the example at the bottom. And this one I gave you 3 things. And if you can, look to see if there's something that goes into all of them. Well, at first glance, they all have an N inside of them. So we know we can pull out an N. They all have an H inside of them. So we know we can pull out an H. They all have what looks like at least an even number. Well, the only even number, or any number that goes into 10, negative 2, and 14, doesn't have to be negative 2. Think of it as just 2. The only thing that goes in all those is 2. So altogether, we said we can pull out a 2, we can pull out an H, and let's see, can we pull out 2 H's? This one we could lose 2. These two, though, we can't lose 2 because they only have 1. So we couldn't pull out 2 H's. We can only pull out 1 H. And the same thing goes for the N. Because this one has 1 N, we can only pull out 1 N. So we're going to pull out 2 HN. That's what's going to happen in this question. We're going to divide all those things, meaning factor out. We're going to pull out a 2 HN. So when I say pull out, it's going to be on the outside of like that, 2 HN. Now, I'm not going to have room to show my work necessarily for these, but it's going to be just like what we did up here when we're asking ourselves. So 10h cubed, n cubed divided by 2hn, basically go step by step. 10 divided by 2, well, that's going to leave us with 5. So we're going to have a 5 left in there. H cubed divided by h, that's going to be h squared. N cubed divided by n, that's n squared. So we're left with 5h squared, n squared for that first term. So this first thing divided by 2hn, that's what it gives us. Now if we do it for our next one, this one right here, we see we have a 2hn, but we have 2 n's, so one of the n's is going to be left behind. But it's a negative divided by a positive, and that's going to be a negative. So that's going to be negative, and we just said only an n is going to be left behind. So that middle one becomes just negative n. Let's look at the last one, and as a reminder how to show your work, if you really want to work it all out, you could do it like this. 14hn divided by 2n. Well, 14 divided by 2 is 7. H's cancel out, and the n's cancel out. Oh, so it looks like you're left with just 7. And it's a positive 7, so it's going to be plus 7, just like that. Alright, so you're done. You have factored this polynomial. You factored out, you pulled out, you divided out, whatever you want to call it. You pulled out a 2hn, and that's what you're left with. And if you're not sure, use the distributive property and multiply all these back together, and you'll notice you'll end up with this. So it does check out. Alright, so far we've been talking about how to factor when you have 2 or 3 terms. But now we're going to talk about what to do when you have 4 or more. For the sake of our class, we're probably just going to focus on 4. But what I'm about to do and show you works for 4 or more. We call it factoring by grouping. Basically, it's going to be used for polynomials with 4 or more terms because we're going to put them into groups based on having something in common, meaning something we can pull out of both of them. So at a quick glance, 8y and 3x have nothing in common. However, 3x and 6, sometimes they'll be next to each other, sometimes they won't be. 3x and 6, they both have a 3 in common. 3 goes into this because you could get 2x. 3 goes into this because you could get 2. So they do have something in common. And if you look at 4xy and 8y, they also have something in common. Granted, remember, they won't always be next to each other, but we want to put them in groups of 2 usually. 4xy and 8y, well, they have something in common. They both have a 4 in them, and they both have a y in them. So I'm now going to be more neat about showing my work, but I want to show you what I mean. Look for groups of them that have something in common, and they don't have to be next to each other. You can always change the order to put them next to each other. So in this example, we didn't need to change the order, so I just went ahead and put parentheses around them so you can imagine them that way. Alright, so let's go step by step. I already said that we noticed both of these, y goes into both of them, and both of them, a 4 also goes into them. So for those, we're going to pull out a 4 and a y. Now if we do that, we're going to be left with On the inside, if we pull out a 4y out of that first one, we're going to have just an x right there. And if we pull out a 4y out of 8y, we're going to have just a 2. And if you're not sure, ask yourself, what is 4y times 2? Well, 4y times 2 is 8y, so we're back where we started, so it does check out. So you factored the first one. You're all done on that one. Now let's do the second one. 3x and 6, well, that one already gave away. 3 goes into both of them. So you're going to pull out a 3, and when you do that, you'll be left with an x for the first term. Now for the second one, 6 divided by 3, well, that's 2. So there you go. So you factored it. Now we're not done, but I want to show you factored both pieces, and now we'll move on to the next step. Now you'll notice they both have an x plus 2 in them. This is especially useful because we kind of want this. Because that's a common factor, in this case it's the greatest common factor, meaning out of everything we did, x plus 2 is inside of all of it. So basically we can rewrite this slightly by saying that because they both have an x plus 2 in them, it's almost like factoring both of them. If you were to say, what do these two things have in common? Well, they have x plus 2 in common. Okay, so just like before, where these had a 4y in common, we say these two things have an x plus 2 in common. So we're going to say x plus 2 on the outside. Now, left on the inside, you have a 4y and a 3 left behind. So you have a 4y and a 3 left behind. And so you actually have what I wrote down here. It doesn't matter what order you write these in. So you've now completely factored this polynomial, and if you're not sure, feel free to FOIL or distributive property twice, whatever you want to call it. Feel free to see that this will still equal, when you're all done, what you started with. So that's how you check your answer. So we have fully factored by grouping in this example. Check out this example and think to yourself, what do some of these terms have in common? Now in this example, I noticed that these two have a 3 in them, so I'm thinking I might put them together. And then it looks like I'm going to put these two together because they both are real focused on x's. So I'm going to rewrite that order slightly so that we can put those next to each other. So I just rewrote that order slightly. I changed nothing. I just changed the order of everything. So we're going to basically factor those, and then we're going to factor these and see if we have anything in common. So let's factor each of them. You'll notice that first one, they both have an x in them, and in fact that's the biggest thing that goes into both of them. So for that first one, pull out an x. Well, x squared divided by x is just x. X divided by x is 1. So that first one becomes this. And if you're not sure if you did it correctly, remember you can always distribute back out and you'll get where you started and check. Alright, so let's do the next one. They both have a 3 in them. So if you pull out a 3, 3x divided by 3 is x, 3 divided by 3 is 1. And so you'll notice, look what you ended up with. You ended up with a common factor. So x plus 1 is your greatest common factor. So meaning we basically only need to write it once. So pretend you are now going to factor these. They both have an x plus 1 in them. So because they both have an x plus 1, let's pull out the x plus 1. And so if we do that, for this one, we'll be left with just, if you divide by x plus 1, you'll be left with just an x. And for this one, if you divide by x plus 1, you'll be left with just a 3. So if you factor it out, I wrote that slightly wrong. Slightly wrong. Remember, we're factoring. There's no plusing there. We're factoring. So it's all multiplying. So multiply, multiply. So everything that was correct, I miswrote. I apologize. We're factoring, which means you could check your answer by multiplying these back out. Feel free to FOIL, like we talked about, or distributive property twice, whatever you want to call it. And you'll notice if you do all that, you will get this exact answer. Before I do another example, as a note, if you ever group them in a way that you notice that when you factor them, you don't have anything in common, feel free to go back to the beginning and group them a different way. There's different ways you could have grouped these to pull stuff out. So if you ever, like I said, if you ever get to the point where you get to this step and then they have nothing in common, they don't both have the same x plus 1, go back to the beginning and group them differently, then try factoring them, and that's all you got to do. You'll find a way that works. And to be honest, it should always, it may not always work. So sometimes it might get ugly, but it usually works. Alright, let's take a look at this example. See what you might think things have in common. I noticed that two of our terms have a y in them, so I'm going to pretend that these go together. And then I'm going to put these together as results. And those, since it looks like 3 goes into my blue ones, 3 goes into both of them, x goes into both of them. So I'm seeing some commonality there. At least with the red ones I marked in red, y goes into both of those. Alright, so I'm going to rewrite this order. All right, so I just changed the order of everything. Haven't changed anything yet. I just changed the order so that the common things are grouped together by something they have in common. So now we're going to factor each of them. The first one, I mentioned 3 goes into 9 and 6, so I'm going to factor out a 3, and x goes into x squared and x. So I'm going to factor out a 3x. So if we do that on the first one, we're going to be left with, let's see, 9x squared divided by 3x. Well, we know we're going to have a 3 and we're going to have an x. Okay, so we're going to have a 3x. And then 6x divided by 3x, well, that's just 2. So the first one becomes 3x times 3x plus 2. Now let's do the second one. I'm going to backtrack slightly. Originally when I grouped these, I kept that minus sign in it, and that might create some confusion. Let's go ahead and not include that minus sign in the second group. That way we pretend, and then we'll worry about that minus sign later, because we need it kind of in between to tell us, before here, it was x plus 3, and that's what went here. So that sign tells you what to put there. So, well, it helps you know what to put there. So I'm going to pretend that the parenthesis comes after it. Like that. So I'm going to put that other step back and then we'll do the red one. Okay, now the only thing that 3xy and negative 2y have in common is just the y. So we're going to pull out the y, and if we do that, we'll be left with 3x for the first one, and for the second one we'll be left with minus 2. So if we pull out the y, we'll have 3x minus 2. So, ladies and gentlemen, we're looking to have something in common like how we did at this step. Well, you might notice, well, we have something kind of in common. So you may have noticed they're close, but we're slightly off by a sign, and maybe it was because of how we grouped them originally. Maybe it would have been easier. We maybe would have had the same sign if we'd included that minus sign and pretend. I'll show you what I mean. What if instead we changed the beginning of that second one? Instead of making that for that negative 3xy we had, we could say plus negative 3xy, so we could have a plus sign in here and have that 3xy now be negative. So now let's see what changes it slightly if we do that. So now if you look at the two things that you have, yes, they have a y in common, but they both technically have a negative in common. So you can imagine, okay, so pull out a negative y, and if you pull out a negative y, watch how the inside changes. For the first one, you're left with a negative divided by negative. That's a positive. You're left with 3x. And for the second one, negative 2y divided by negative y, well, that's just positive 2. So now look how it's written. You'll notice you now have a common factor inside of these. So my point is, you can manipulate them if you notice you're getting close, if it's just a sign issue. Try to see if you could have written it slightly different at a different stage to help you get it to come out to where when you factor, you have a common factor. Because now that we have a common factor, we can imagine that we're factoring this whole thing, and out of this whole thing, we can pull out a 3x plus 2. So if we pull out a 3x plus 2 out of the whole thing, out of this one, we're left with just 3x. We'll have just a 3x right here. And if you pull it out of this one, you'll be left with just negative y, or minus y. So in fact, this is your full factoring. 3x plus 2, all of that times 3x minus y, these are your two factors. And I'll say it again, I've said it once, is if you FOIL this, or you distributive property twice, whatever you want to call it, and if you check this, you'll end up with the exact same thing that you started with. Alright, so this is your answer. 3x plus 2, all that times 3x minus y. Alright, this is going to be our last thing. So I took my time, we talked about how to factor some polynomials when there's something you pull out of everything, or by grouping. But now let's pretend it was an equation and you're asked to solve by factoring. Well, I'm going to start and pretend that it was already factored for you. And basically you're going to use the zero product property. And in other words, let's read this. If the product of two factors is 0, meaning multiply two things, if it equals 0, then that means one of these things must equal 0, or both technically, because if this whole thing equals 0, okay, if this whole thing equals 0, it doesn't matter what this is, anything times 0 will equal 0. Or vice versa, if this whole thing equals 0, meaning no matter what this is, anything times 0 will be 0, or if they both equal 0, 0 times 0 is 0. So that's going to be the answer to this equation. You're asking yourself, what would make this equal 0? What would make this equal 0? And your answer is one of those or both of them. So here's what I mean when you say what would make it 0, meaning what could make this whole parenthesis equal 0? Imagine there was a 2 right there. 2 minus 2. Oh, well, that's 0. Oh, so there you go. That means one of your answers is x equals 2, one of them. Now you could full on show your work like this. Take that left factor and say, all right, make it equal to 0 and solve, and you get x equals 2. Now if you do the same thing for the right one, okay, so 4x minus 1, what would make that equal 0? Let's see, we'd add 1 to both sides. 4x equals 1, divide by 4, you get x equals 1/4. So that's actually your other solution. So the answer to this question, the solutions to this question, are going to be 2 and or 1/4. So your answers are x equals 2 and 1/4. Those are your solutions. Those two things would make this equation equal 0. So this equation has two answers. Either of these would make it equal 0, or both happening at the same time, so be it. But remember, if this is like an input-output situation, you would only plug in one at a time. So to be more clear, we can just say or. We'd say 2 or 4, or 2 and 4. It really doesn't matter, because if you put a 2 here, that equals 0. If you put a 2 here, that equals 8 minus 1, that equals 7. Well, 0 times 7 is still 0. So plug in one at a time, and that's what you get. So your answers are 2 and 1/4. The nickname for this is also called finding the 0 of your factors. Remember, this is a factor. These are both factors. Factor, factor. Finding the 0 of your factors. When I say find the 0, they're saying find what would make it equal 0. In other words, you're finding what values of x will make it. Pretend there's a y out here if you want. What values of x will make y equal 0? I said it backwards. No, I said it right. What values of x will make y equal 0? In other words, what are the x-intercepts? That's a foreshadowing to what we're doing in the future. For now, let's call it solving. All right, so see if you can try this one. See if you can find out what would make each of these factors equal 0. Well, if you imagine that x was 0, 3 times, because that's 3 times x, 3 times 0 is 0, so 0 is going to be one of your solutions. X equals 0 is one of them, because x equals 0 would make that first one equal 0. Now for the second one, 2x minus 1 equals 0. Imagine what would make 2x minus 1 equals 0. So think of it as maybe showing your work if you need to. And you'll find out x equals half, 1/2, for the steps I already showed. So if x is 1/2, in other words, 2 times 1/2 is 1. 1 minus 1 equals 0, so this whole thing would equal 0. So 1/2 is one of your answers. So the proper way to write your answers is this. Technically, we're finding sets of numbers that are our answers. These little braces or brackets, we use these for lists of numbers. So 0 and half, those are the solutions for x to this question. Sometimes you'll be given the equation, like in example 2, to where you won't have it equal to 0. Well, so the first thing you're going to do is make it equal to 0, meaning move everything to one side. So let's move that 6a to the other side. It's positive 6a, so the opposite is negative 6a. So if we do that, we'll have 3a squared minus 6a, and now equals 0. Now you're ready to go. Except, hey, it's not factored. So if it's not factored already, use what we were talking about, in this case, the beginning of the video, and factor it, and then find the 0 of those factors. Well, 3 goes into 3 and 6, and a goes into both of them also. So the biggest thing that goes into both of them is 3a. So if you pull 3a out of the first one, you'll be left with just a. And if you pull 3 out of the second one, you'll be left with just minus 2. So, and if you're not sure, go ahead and distribute this back out to check yourself. 3a times a minus 2. So all of that equals 0. Now you just have to find the two zeros. Well, ask yourself, 3 times what would make it 0? Well, the answer is 0. So that means one of your solutions is 0. Oh, it's just like the one up here for the same reason. So one of your solutions is x equals 0. Then ask yourself, what would make this one equal 0? Well, I think you can already imagine if that was a 2. 2 minus 2 is 0. So your other solution is x equals positive 2. Now, if that had been a plus 2 right there, you would have said negative 2, just as a note. All right, so those are our two answers. All right, I'm going to stop it here. This video is getting kind of long. I just want to really explain factoring, and then if it was an equation and you can solve it by factoring. Not every equation factors pretty, but for now, everything we do will factor pretty. These are the tools you need for what we're going to be working on next chapter. All right, so we talked about factoring just by looking to see if they had something in common, so such as these examples. We talked about factoring by grouping, meaning maybe putting them next to each other in an order that would help them have something in common, and then factor. And then when you factor, you were looking for a common factor between them, because that common factor, you notice, became your thing on the outside. Or we're pretending this is called the inside and the left one's called the outside. And you're doing it, and then you're putting it all together just like that. And then now we talked about solving by factoring, which is if you're given the factors, what makes the factors equal 0? or if it's not factored for you already, go ahead and factor it. Once you make sure it's set equal to 0, factor it, and then what makes those factors equal 0. So we're done with this section. We've accomplished our goals of factoring and then solving by factoring. Now come to class with questions ready, and we'll do a ton of examples in class. Good luck, guys.